10.3 qualitative changes in equilibrium systems. Okay, so there are principles that if you disturb the equilibrium, the system adjusts in a way that opposes the change. Okay, now we'll see that what are gonna happen here. Look at this. We have CO2 turning into the CO and O2. It's a two-way reaction, so equilibrium will establish. As you said at the beginning, if you have some CO2, so it turns into the product, so the concentration decrease, go down. We had nothing at the beginning for CO and O2, so the concentration of the CO and O2 started at 0, increased. And after that, sometime the equilibrium at this point was established, right? When the equilibrium is reached, you look at that, see the concentration of CO2 is jumped. It means we added loss of CO2 into the system. When you do that, it means you are disturbing the equilibrium. According to the law of change, it said that the equilibrium adjusts itself in a way that opposes that change. Since the CO2 increased, so it means this side has increased, right? So it doesn't like it. You have to oppose it. This increase means you have to go forward. You need to consume it. But the forward reaction happen. If the forward reaction happen, what's gonna happen? So concentration need to go down. But since this is forward, concentration of CO and O2 need to go up. See, let's go up and let's go a little bit up. And as you see, after some time, again, the equilibrium will establish. But it's very important that you realize what is happening when we disturb the equilibrium. When you add CO2, what is that? The student need to be able to draw, and when we say that the CO2 has a system, you need to draw such a things. Looking at the next one, again, at the beginning you have this, and when the equilibrium is reached, you see sudden decrease in CO, means you remove CO. When you remove CO, you need to adjust to oppose that. You're removing CO means you have to produce CO. You need to do the reverse. You remove CO, now you have to put it back. So forward reaction need to happen. Again, means CO2 will decrease because it's now forward, and O2 and CO2 increase. See, CO2 increase a little bit, O2 increase a little bit, and then again, the equilibrium will establish after some time. See, this concentration become constant. So they're gonna be the same thing here. So Fe, the concentration, we have some concentration, Sn, we have some concentration. Go down, the equilibrium established at this point. Of course, this we have nothing at the beginning and then increase, and here is the equilibrium reach. So this is sudden increase in the black one. So the black one is Fe, means you put a lot of Fe into the system. That's why it jumped. And since a lot is here, it need to go forward, need to be consumed, because you need to oppose that change. Yeah, this now you have to remove it, means to go forward. As you see, this is forward. Forward means the concentration of these two need to go down, concentration of this need to go up. So again, you're disturbing by, the concentration of the SCN is jump, means you're putting a lot of SCN. Your system is jumping. Now, the equilibrium needs to oppose that, means you need to be consumed. But it's going to go forward. See, the forward reaction need to happen. It means concentration of Fe and SCN need to decrease, go down. Concentration of that need to go up. And here, what is happening now? The concentration of the FeCN is jumped. It means you put a lot of that there. So the equilibrium need to oppose that change. Loss of that here, it need to be consumed. So backward reaction need to happen. So it means the concentration of the FeCN here need to go down, and concentration of these two need to go up, as you see there. Now let's see what happens if we change the temperature. To do that, we need to know if the if the reaction is endothermic, it means the energy is on the right side, sorry, left side. And if it's exothermic, the energy on the left side is producing energy or it's consuming energy here. Okay, look at this. If I increase the temperature, what's gonna happen, do you think? Increasing the temperature, so it need to oppose, the system need to oppose to what I did. I increase the temperature, so this need to go in a direction that consume the heat or decrease it. So if you go forward, energy will be absorbed, means it will cool down the system. So if I increase the temperature and go to a direction that cool down the system. Again here, this is exothermic. If I increase the temperature, so you go into a direction that cool it down. So you have to go backward, because the backward is when the energy is absorbed and it will be cooled down, right? Now look at this. As you see, this is what is happening. The equilibrium is reached and after it's disturbed. So it's going down. So means these two going down means is forward reaction, right? Is forward reaction. What change I did that it went forward? It means I did cool down the system. That's why it had to go in the direction to produce energy. It opposes what I did. So what I did is cool down. So it decided to go forward to create more energy to heat up the system. So here is the same thing here. See, it is this is increased and these two decrease. So these two decrease, this is increase means this is the reaction going to be in this direction. So what I did that it decided go to backward direction. So going to the direction that produced the energy, right? What I did, maybe I did cool down the system that it had to go to the direction to produce energy to heat up the system. So it's going to be a cool down. So it means I decrease the temperature and it went the direction to heat it up or increase the temperature. So always remember what you do. The equilibrium want to go in the way to reverse what you did. So let's just see what happened if I increase or decrease the volume. What happened when the volume changing? When the volume changing, you have to look at how many mole is on the right side and left side. On the left side, you have 3 plus 1 is 4 mole totally. On the right side, you have 2. If you have more space, means you increase the volume. It would like to be on this side because we have more space, or we can have more mole. If I decrease the volume, I have less space, so it prefer to be this in this 2 mole side. So it depends what you do. Okay, so let's just look at that. So here the equilibrium reached at this dotted line, and what happening after that is decrease, decrease, increase. It's going forward. It seems that it's going forward. So, whoa, what changed in terms of the volume I did? Because here we have 2 mole, we have 3 mole. You wanted to go toward less mole, means what I did, I decreased the volume. I have less space. That's why it went direction with less mole. If you notice here, all of these jumped. It means because you're decreasing the volume, the concentration of everything is jump. And then the system need to go toward lower more, and it would be forward. So that's why it's decrease, decrease, and here is increase. So what is not affecting the equilibrium system? If you add a catalyst, it won't affect your equilibrium because the catalyst just increase. It will lower the activation energy, but the rate of energy forward and backward will be See, backward activation energy is from here to here, and forward activation energy is from here to here. So backward and forward activation energy will be decreased. That's why it just make your reaction to get to the equilibrium faster, but it won't change the direction of this reaction. Also, adding inert gas. Adding inert gas will not affect the equilibrium. So here is the summary: concentration, temperature, volume, what happening, what kind of shift you have, and also catalyst and inert gas, which have no effect. You can find this table to be useful to do the review for summary. Okay, so to do some questions, this is page 457. Question number 3, you can try. Also, question you can do question number 2, question number 3, question number 6. This is page 459.